Lesson 7.5, Solving Rational Equations. All right, to solve rational equations, there's two methods. Both are only when the equal sign is present. These are equations now, not expressions. Equations means equal signs. So what we're doing is only when there's equal signs. First method is to simplify both sides. That's doing your adding, expressions, multiplying, getting it together, and then cross multiplying. That works if they're simple. However, it can lead to some nasty polynomial equations to solve. Method 2 works all the time and is usually simpler. But it's only when the equal sign is present. Multiply both sides by the lowest common denominator to remove the fractions. Solve your equation and check your answers. Yes, it's possible to get extraneous solutions, which are solutions you get while you solve but don't work when you check them. So let's try page 390, number 5. This one is simple, so we could try cross multiplying if we want. So if I cross multiply, I'll have x times x minus 1 equals 2x plus 7 times x minus 5. All right, we're going to need to multiply this all out, so distribute x squared minus x. Here that's 2x squared minus 10x plus 7x minus 35. This appears to be quadratic, so let's get everything on one side so it equals 0. So I'll subtract x squared from both sides and add an x to both sides. So 0 equals x squared. I have negative 10x plus 7x is negative 3x plus x is negative 2x minus 35. Well, I like to try to solve these by factoring, so let's give it a shot. Who knows? What times what makes x squared is x times x. And what times what makes negative 35? We want it to add to make this negative 2 in the middle. So see, 35 is 7 times 5. So maybe if we did a negative 7 times positive 5. They multiply to make negative 35 and add to make the negative 2. So hey, that works. Then take each factor equal to 0. So it looks like we get 7 and negative 5. You need to check those by plugging them back in. And if you do so, they both work. Why don't you try number 1? Pause it while you solve it. You should get only one answer, and your answer is 4. Let's try number 21. All right, as you can see here, now it's a little bit more complex. It's not just fraction equals fractions. The easiest way here is we're going to multiply by the lowest common denominator. So that means we have to figure out what that is first. So we only have the two different denominators, x plus 4 and x minus 1. And you make them by multiplying, so it would simply be x plus 4 times x minus 1. So I'm going to multiply everything by that. All right. Maybe I'll write it out so it looks nicer. So this is legal because I'm multiplying both sides by the same thing and then distributing to both terms on the left. All right, notice that x plus 4 cancels. And we could distribute the rest. So that'd be 6x squared minus 6x. Here, let's multiply the binomials first. That'd be x squared minus x plus 4x minus 4. We'll distribute 4 in the next step. And then here, the x minus 1s cancel. And we can distribute what's left. So that'd be 2x squared plus 8x plus 2x plus 8. All right, let's distribute the 4. So that'd be 4x squared minus 4x plus 16x minus 16. And those would make 10x. All right, so now it's quadratic. Let's get like terms together. So I'm going to subtract 2x squared from both sides. I'll subtract a 10x from both sides, and I'll subtract an 8 from both sides. So for x squareds, I have 6x squared minus 2x squared is 4, plus 4 was 8x squared. For x's, I have negative 6, negative 10 is negative 16, plus 16 is 0, minus 4. And for just the numbers, I just have those, so that'd be negative 24. All right, let's try factoring. Factor out a common factor of a 4. And then let's see if we can factor this. So what times what makes 2x squared is 2x times x. And to get a 6, how about 3 times negative 2? So how does that give me my negative x? Well, we do our first. It's negative 4x. And 3x makes negative x. So outers plus the inners should give us the middle. So then I take each factor equal to 0. So I get x is negative 3 over 2, and x is 2. Check both those answers, plug them in. Yes, they do work. Would you pause it while you do number 17? You'll get one answer, and it should be 2. Next, we're going to figure out how to determine whether the inverse of a function is a function. So, the inverse switches the x and y. So that means, remember, a function is when any one x gives you one y. So the same x value can't give you more than one y value. Well, if I switch the x and y, that means the inverse then would be a function only if the same y value is only once. So we'd graph the function and use the horizontal line test. And if that touches the graph more than once, then the inverse is not a function. Remember, if we're just looking for a regular function, if it was a function, you use a vertical line test. To see if the inverse is a function, you do a horizontal line test because the x and y's are switched. To find the inverse, you switch the x and y's, and then you solve for y. All right, so let's try page 391, number 35. We have this function. We need to determine whether it's an inverse is a function, and then find the inverse. So if I look at this graph, I can see that any horizontal line that I draw only touches once. Therefore, it passes the horizontal line test, and the inverse is a function. Now to find the function, we need to switch the x and the y. So this is our function. Remember, f of x is the same thing as y. I'm going to switch the x and the y, and then we need to solve it for y. So let's multiply both sides by a lowest common denominator, the y minus 4. That side they cancel out, so it just equals 2. Now to solve for y, let's just get everything away from the y. So we'll divide by the x, and then add 4. And you can see that it is another rational function. Actually, usually we would probably write it as inverse f of x. That'd be better, putting the f to the negative 1. That means it's inverse. Why don't you try number 37? Pause it. All right, your answer should be yes, it is an inverse. And then inverse f of x is 3 over x plus 2.